Finding a Place to Live Part 2. Today we're going to be talking about some of the expenses involved in moving. And we're going to be reviewing systems of equations in that context. We'll be able to calculate moving expenses. Sometimes when people move, they use a moving company. Sometimes they can hire them for different things. They can just bring the truck, and then you can load it, and then they can drive it to your destination, or they can literally come in your house, pack up the boxes, put them in the truck, drive the truck to wherever you're moving, unpack the boxes. They can even put them in certain rooms. So depends on how long you're going to need the company, what are you going to have them do, how far you're moving away, yada, yada, yada. So like I said, we are going to be talking about these in terms of linear equations and systems of linear equations. Remember, a linear equation is any equation with two variables, and those variables cannot have an exponent greater than 1. So any two variables that describes a straight line. So an equation that when you graph it, it is a straight line is a linear equation. You've learned different forms of linear equations. This is standard form. You've also learned slope-intercept form in algebra, point-slope form in algebra. Remember that there are 3 types of solutions to a linear equation. Actually, I think I'm getting ahead of myself. So given the linear equation like 2x plus 3y equals 10, there are an infinite number of solutions to the problem. So a solution to an linear equation is an ordered pair, an x value and a y value. So on this line, any point on this line is technically a solution to this equation. Thanks. So if we can look at any point, but we're going to look at a point that is easy for us to see what the coordinates are. On a graph like this, you can't see what the coordinates of this point are, but we can see what the coordinates are if the line crosses at where it crosses at a grid lines that intersect, right? So we know that this ordered pair is 3, 0. If I plug 3 in here and 0 in here, the left side will equal the right side. So if we plug 3 in there, 2 times 3 is 6, plus 3 times 0. Oh, did I do that right? Yeah, that's not the equation for this line. But anywho, if that were the equation for that line, it would make it true. That's weird. Okay. Anywho, we graph things to get a better idea of what it looks like. I think what you guys are probably seeing in some of the do-it-yourself notes and the Nearpods and stuff we do. We look at infographics, we look at graphs that they give us, because the business world, the financial world does present their data in different ways, and a graph is a very visual way. Usually it's the top right-hand quadrant, so quadrant 1 of that graph, but it is a very common way to present information. The line describes every pair of values when the equation is true. A system of equations, any pair, and it could be more. We're only going to work with 2 equations at the same time. When you have more than one equation in the same world, there are only 3 options. So a system of equations, remember, 2 linear equations where the x and the y value in that system have to be the same value, right? So we don't know what it is. We know it's the x and y, and we know if it's in that same world, then it would be the same value. So the normal solution, the solution we're going to be working with normally is when the graphs touch once or the lines intersect, we know we have one solution. When we have one solution, that solution is an ordered pair. Now, a real-world problem, we would not write the answer as an ordered pair, but it still could be represented on a graph. It would be represented on a graph that way. So if you're solving a system of equations and you can solve for x or solve for y, we know that we have one solution. If we solve for one variable, we can solve for the other. Now, if you remember back to algebra, sometimes when you are solving systems of equations, sometimes your variables are going to disappear. So if you remember, when your variables disappear, you might wind up with something like 9 equals 0. If your variables disappear and that statement you have left is not true, 9 equals 0 is not a true statement, then we know that there's no solution. Is that what this means? Yeah. And on a graph, you would see that those lines never touch, so parallel lines. But when you're working it algebraically, the variables have disappeared and you have a false statement. If you graph one of the equations and then you graph the other equation and it winds up being right on top of the first, then we know that their graphs always touch, and there's an infinitely many number of solutions. So every ordered pair on that line makes both equations true. And there's an infinite number of points on the line, so that's why there's an infinitely many solutions. So if we're solving algebraically and the variables disappear, but it's a true statement, so let's say it's 9 equals 9, now we know that there's infinitely many solutions. Any questions? All right, so the steps to solving a system of linear equations, we only have to work with two equations in our system. The first thing you want to do is find a pair of coefficients that can easily be modified to become opposites with its partners. I would say that actually the first thing we want to do is make sure we have our equations written in the same form. We want all of our like terms from one equation to be lined up vertically with the other equation. So, for example, 2x and 3x, they need to be lined up. 3y and y, constant and constant. We could have this written as 3y equals negative 2x plus 10, but then this would be y equals negative 3x plus 8. We have to put them in the same order. Does that make sense? And the reason is because we are going to be stacking opposites. So when you add opposites, first of all, do you know what opposites are in math? What are opposites in math? Anybody? A negative is part of an opposite. So what's the opposite of negative 3? Positive 3, right? So opposites have the same absolute value but a different sign. So negative 3 and 3 are opposites. What happens when you add negative 3 and 3 together? You get 0. So opposites always add up to 0. What's the opposite of 8? Negative 8. When we add 8 and negative 8 together, we get 0. So we are stacking, putting them in order, and then looking at our stacks. So here, we want to be able to add, so when you were in algebra, you learned 3 ways to solve systems of equations. You learned how to solve them by graphing, which is very imprecise. You learned how to solve them by substitution, which is fine. And then you learned how to solve them by elimination, and I always give the choice, I always pick elimination. And that's the strategy we're going to use here. So we're going to look at these two equations and see, can we eliminate an x or a y term in both the equations, right? How are we going to do that? We're just going to add them together. We're going to line them up and add them together. If we could just add them together and get rid of the x's or get rid of the y's, then we would do that. We can't do that, so now we're going to look at what we need to multiply so that we have opposites stacked together. So let's look at this first example. 2x and 3x. I can't add them together. I can't just multiply one by negative 1 and add. They're two positives. And that's okay. We could do that, but we'd have to multiply both equations by a number. That's okay. Sometimes we're going to have to do that. But I do see 3y and y. I can easily multiply y by negative 3y, and now I have opposite steps. Does that make sense? And when I add 3y and negative 3y, now I've eliminated one of my variables. Remember, we're eliminating because we can't solve an equation with two variables. Right? We can't isolate a variable in an equation with two variables unless we're working with a system. All right, so let's do that. So this second equation, we're going to multiply everything, or we can do whatever we want to an equation as long as we do it to everything in the equation. We do not change the value of it. So we're going to multiply this equation by negative 3. So that's negative 9x. Negative 3 times y is minus 3y equals, a lot of times kids forget to multiply this part, negative 3 times 8, negative 24. Now, I'm going to bring this first equation that I didn't do anything to down. I'm going to stack it underneath. And now I can add them together. And as planned, my y's are going to be eliminated. So negative 9x plus 2x is negative 7x. Negative 3y plus 3y, that's 0. Negative 24 plus positive 10 is negative 14. I'm going to solve that equation by dividing both sides by negative 7. And now I know that x has a value of 2 in this system. That means it's 2 in both equations. So I know now that I only have one solution. I know that the x-coordinate is a 2. Anybody remember how to find the y-coordinate? Remember how to find the y-coordinate, Brady? Okay, that's all right. So we can take this 2 and we can plug it back in to either of these original equations. Right? So I'm just going to use the first one, 2x. So now we know that x is 2. It's 2 times 2 plus 3y equals 10. Now I have an equation that only has y for the variable. I can isolate the y to solve for y. So 4 plus 3y equals 10. Subtract 4 from both sides. 3y equals 6. Divide both sides by 3, and now we know that y equals 2. So the x-coordinate and the y-coordinate, the solution is 2, 2. And we can, just so you can see, 2 times 2 is 4. Plus 3 times 2 is 6, that equals 10. So that works. The left side equals the right side. Here, 3 times 2 is 6, plus 2 is 8. 8 equals 8. So you'll see that the ordered pair that we solved for makes both equations true. Any questions? All right, we're going to do the next one. Can you see at a glance what's a product that both coefficients on the x or both coefficients on the y are a factor of? Say it again? No, 2 is a fact. Yeah, so the product would be 16, right? 8 and 16 are both factors of 16. Yeah, so if we had 16y and negative 16y, we'd get rid of y's, right? And we don't have to do anything to this one, but we have to multiply this one by negative 2. If you're stumped, that part doesn't make sense to you, you can always just multiply, and then to find your product, make one positive, one negative, and then you can figure out what factors you have to multiply by. But here, this one's pretty straightforward. Negative 20x minus 16y equals negative 404. So now we're going to take this one and stack it below it. We didn't do anything to that one. We didn't have to. And now we're going to add them together. Negative 20 and positive 12 is negative 8x. Negative 16 and positive 16 adds to 0. Negative 104, positive 300 is negative 104. Sorry, negative 404 plus 300 is negative 104. We divide both sides by negative 8. We find that x in this system is 13. So we know the x-coordinate is 13, and we can stick that back in, plug it back in to solve for y. It doesn't matter which one. I did the first one here, so I'll do the second one here. This says pick the easy one, but honestly we could use a calculator, so they're all easy if you use a calculator. So let's do 12 times 13 plus 16y equals 300. Now I have an equation with only a y, only one variable. 12 times 13 is 156. Now I'm going to subtract 156 from both sides, and 16y equals 144, I believe. And now we're going to divide both sides by 16. To find that y equals 9. So if I plug 13 in here, will it equal, and 9 in for y, will it equal 202? Well, 10 times 13 plus 8 times 9 does in fact equal 202. If I plug 13 and 9 into the second one, 12 times 13 plus 16 times 9 equals 300. That's what it's supposed to equal. Any questions? All right. Which would be the easiest to eliminate in this third one, the x's or the y's?
The y.
The y's, yeah. What can we, if we eliminate the y's, we can multiply just one of the equations by a factor. And we can multiply this one by negative 2 again, right? Because 10y and negative 10y would be easy to stack. So negative 2 times positive 5 gives me my negative 10y. So I'm going to distribute that to everything. And now I'm going to bring back my first equation that I did nothing with and stack it underneath it. And now I'm going to add them together. Negative 6x plus positive 7x is x. As we design, those simplify to 0. And now we know x equals 8. Negative 168 plus 176 is 8. So that is our x coordinate. See if you can find the y coordinate. Hey, Caius, you awake, buddy? Anybody get the y coordinate yet? Chris? 12. Did you get it, Kevin? Got 12 as well? All right. We'll plug it in. I'm sure they're right. I'm going to put it in, but we're just going to show everybody else. So I'm going to take either equation. I'm going to take that first one. 7 times 8 plus 10y equals 176. That's 56 plus 10y equals 176. Subtract 56. That's 10y equals 120. Divide both sides by 10. And indeed, that y value is, y coordinate is 12. So if I plug 8 and 12 in for x and y in both equations, it makes both equations true statements. Any questions? All right, we're going to start by seeing some typical expenses that you might pay and how it's presented to you for moving. We are going to write a system of equations, but not yet. New home movers charges $95 per hour for loading and unloading services. So you've already got the boxes packed. You've got them in your house. They'll pick them up from your house and put them in the truck. When you get the trucks, when they drive the trucks to wherever you're moving, they'll take the boxes out of the truck and unload them and put them in your house. Make sense? They also charge $80 for packing and unpacking. So they will fill your boxes for you before they load and unload them, if you like. And then when you get to your new house, they will unpack your boxes for you as well. I've never used a real mover to move, so I think it would be great. One of the things, if you are ever applying for a job and you've got to relocate to a new city, sometimes your employer will pay your expenses for that, and then it would be great to try a moving service since they pay for it. But you may have to do the work and price it out, or maybe you decide you don't want to do it, right, even if your employer won't pay for it. But that is actually one of the things that you could shop for. Remember we talked about when you're applying for jobs, it's not just straight salary. It could be other things that benefits that you're looking at, and if all things being equal, if one company is going to pay your moving expenses and one company is not, then you may want to go with the company that's going to pay your moving expenses, because you'll see that moving can be pretty expensive. It can be thousands of dollars. All right, so in addition, they charge a price per mile for truck rental. In this case, it's $250 per mile. Jay is moving 200 miles. He needs 9 hours of loading and unloading and 7 hours of packing and unpacking. We don't really have to write an equation here, but we are going to write an equation. We're just not going to have variables because we already know all the costs. So later on, we're going to write a very similar equation, but we won't know what it is per hour to load and unload. We won't know what it is per hour to pack or unpack, or we might not know what it is per hour or per mile for the truck rental, right? But for right now, we know all of these things. We know the loading and unloading is, he needs 9 hours, and we know it's $95 per hour. So that's the first part of the expense. We know he's going to pay $80 per hour for packing and unpacking, and we know he needs 7 hours for that at $80 an hour. We know they're going to charge him $250 per mile for truck rental, and we know he needs 200 miles, so that's 200 times 250. And that is our subtotal before tax. So $1,900, $1,915 plus tax. So pretty pricey. So we're going to take a shortcut for the tax. You could take 7.25% and then add it to that. But there's an easier way since we get to use a calculator. We can use 100% plus 7.25%. We can multiply, so that's going to be equal 107.25%. Does that make sense to everyone? So if we multiply 1915 times 100%, we just get 1915, right? But if we multiply it by 107.25%, we're going to get this amount plus 7.25% more. So that's what we want to do. So it's going to be 1915 times 107.25%. You can convert that to a decimal in your calculator if you want, but you don't have to. There's a button. There's a button on your phone. There's a button on your calculator. You can always do that. So if we do that, we get $2,053.84. So that's the price for moving using this many hours for loading, unloading, packing, unpacking, and the miles of the year. Any questions? All right. We move you, charges for moving according to the rate schedule shown. Nikki is moving a distance of 150 miles and needs 7 hours of loading and unloading and 5 hours of packing and unpacking. What will her moving cost be if the service also charges 8% tax on the total? Well, they tell us the price per hour for loading and unloading, so let's see how many hours they need. We need 7 of those hours. $70 per hour for packing and unpacking, and here they tell us she needs 5 hours of that, so it's 5 times that hourly rate. They tell us it's $5 per mile for truck rental, and she needs 150 miles. So for finding that net cost before tax, it's $1,695. 7 times 85 plus 5 times 70 plus 150 times 5. So now we can take that $1,695 and multiply it by, in this case now it's going to be 100% plus 8%, or 108%. So times 108%, and that would give us $1,830.60. That would be her total cost for loading, unloading, packing, and unpacking, and the per mile cost for running the truck. Any questions? All right. A moving company gave Mike 2 quotes, determined the hourly rates for loading and unloading, and packing and unpacking. So now we are going to be writing equations, in fact, writing a system of equations. They tell us how many hours of loading and unloading. They tell us how many hours of packing and unpacking, and the total cost for the move for both scenarios. So scenario A, scenario B. They're in the same world. They're the same moving company. So we know that the cost per hour for loading and unloading should be the same in either scenario, and the cost per hour for packing and unpacking should be the same in either scenario. The first thing we have to do is we have to define our variables. In other words, we know, let's look back over here real quick. If we didn't know how many hours, we could have written this, we could have written a generic formula for this, so we could plug in the hours and the miles if they change, or if we were to adjust. This would have been, we could have used X to represent the number of hours. We could use Y to represent the number of hours loading, unloading, number of hours packing and unpacking, and number of miles for the truck rental. If we did that, you don't have to write this, but just for an example of what we're going to be doing on the next slide, that would be 85X plus 70Y plus, I didn't write another variable, let's see, 5 Z equals that total cost. All right? So if we don't know how many hours or we don't know the price, we can write an equation with variables in those spots. And that's what we're going to do here. We do know how many hours. So let's define our variables as, we're going to use X here. We're going to say that X is the price per hour for loading and unloading. And that would be in both scenarios, right? And we're going to say that Y is going to be the price per hour for packing and unpacking. Does that make sense? All right. And the total cost, we don't have to have a variable for that. We already know what that is in both scenarios. So if I'm writing the equation for scenario A, it's going to be 3 times X, so 3 hours at some price that we don't know to pack and unpack, plus some price times 2 hours, or I did not, loading and unloading, packing and unpacking it, that's right. So this represents how much they charge us per hour for loading and unloading. This represents how much they charge us per hour for packing and unpacking, or how much they're charging Mike. What do you think is going to be the equation for the other scenario? Perfect. Exactly right. So now we have a system of equations, and we can eliminate one of the variables and solve, just like the strategy we reviewed at the beginning. So to do that, I've got a positive 2y in both. If I can turn this one into a negative 2y, now I've got opposites, right? So I'm just going to multiply this whole equation by negative 1, and then I'll have opposites. So negative 5x minus 2y equals negative 680. And I'm going to bring this one down to stack it and add them together. So these eliminate as we planned. Leaves me negative 2 times x equals negative 200. So I'm solving for the price per hour for loading and unloading, dividing both sides by negative 2. So I get x equals 100. Now, in a real-world problem, we don't write this as an ordered pair. We do need to write it in a form that makes sense for this problem. So this is $100 per hour for loading and unloading. That's what that 100 represents. That is the cost, the price per hour the movers charge for loading and unloading. So now we can find the price for packing and unpacking by plugging in 100 in one of these and solving for y. So we know x is 100. I'm going to plug into the first one. So 300 plus 2y equals 480. Subtract 300 from both sides. 2y equals 180. Divide both sides by 2, and now I know y equals 90. But I need to be able to tell what that means. And that means that the movers are charging $90 per hour for packing and unpacking. So far, so good? All right. I'm going to do the same thing here. Use X for loading and unloading, Y for packing and unpacking in both scenarios. So X equals the price per hour for loading and unloading. Y equals the price per hour for packing and unpacking. Whatever the price is times 8 hours plus whatever the price is times 6 hours equals their total cost of $8.90. So weekday move versus a weekend move. 5x plus 3y equals 515. Anybody see what we could multiply one of the equations by to eliminate one? Chris?
Multiply the second one.
Perfect. So 6y and 3y, they're both a factor of 6. If I can multiply this by 2, I've got 6. So I can multiply by negative 2 like Chris said. Now I have negative 6. So that's what I want. I want one positive and one negative. So I'm going to multiply this by negative 2 because that gives me my negative 6y. So negative 10x minus 6y equals negative 1,030. Every term. We're going to stack that first one that we didn't mess with right below it so we can add them together. Negative 2 times x. Our y's are eliminated as we wanted. And that leaves me negative 140, I think. Yeah. Divide both sides by negative 2, and now we know that x equals 70. So x represents the price per hour for loading and unloading, so that's what we're going to write. $70 per hour for loading and unloading. You also have the price for packing and unpacking. Anybody got it yet? What'd you get, Kevin?
55.
Anybody else? Chris? 55. Anybody get something different? All right. Plug 70 into the first one. Doesn't matter which one. Now we have an equation with just one variable. Isolating the y by subtracting 560. What is that? 330? 330. And then 330 divided by 6, I assume it's 55. All right. So what's that represent? This is what it represents for loading and unloading, right? So it represents $55 per hour? Yes, for packing and unpacking. Anybody have a question? All right. Samantha's moving from Madison, Wisconsin to La Crosse, Wisconsin. She'll do all of the packing and unpacking herself with the help of her brother. The moving company put at a price of $12.50 for 8 hours of loading and unloading and driving 130 miles. The company quoted the same price if the truck drives an extra 30 miles to pick up Samantha's brother. She figures with her brother's help she only needs to hire the movers for 6 hours. So how much does the company charge per hour for loading and unloading? That's what we're going to use X for. And how much do they charge per mile for driving? So we're going to define Y as the price per mile. Any questions?
Yeah, mine was one.
Did you get C? I saw somebody else do that this morning, and I asked the thing to staple. I think I did. I swear the first ones were stapled. Who knew? Okay. So we'll get two scenarios. This first one is it costs $12.50. Well, they both cost $12.50, honestly. They both are going to equal $12.50 both scenarios. So we're writing two equations, and we're going to solve for the price per hour for loading and unloading, the price per hour per mile for renting the truck. So this first one we know is 8 hours of unloading and loading, so that's times X, right? And driving 130 miles, so that's times Y. So our first equation, pretty straightforward, 8X plus 130Y equals 1250. Now it says that they have agreed to charge the same price, but they're going to be going an extra 30 miles, so it's going to be 160 miles for the second equation, and only 6 hours of packing and unpacking. Oh no, loading and unloading. So 6 times the price for loading and unloading plus 160 miles for renting the truck. We have one more example after this? Okay. I'm going to kind of pop through this one a little quicker so I know we don't run out of time. All right, I know that I'm going to look for 24x here because those I know are both factors of 24. So I'm going to multiply this one by 3, gives me my positive 24, and this one by negative 4, it'll give me my negative 24x. So I'm going to multiply both. And that's 3750 negative 24x minus 640y equals negative 5,000. So what y'all got? All right, we're eliminating our x's this time. So that's negative 250y equals negative 1250. So now we know, if we divide both sides by negative 250, we know that y equals 5. So that's $5 per mile they charge. Going to use the y to plug back in, 8x plus 130 times 5, because that's where the y goes, equals 1250. X plus 650 equals 1250. Subtract 650 from both sides. 8x equals 600. 600 divided by 8 is 75, I believe. Yeah. So that 75 represents $75 per hour they charge for loading and unloading. Any questions? All right, last one. We're going to use, so we're loading and unloading and miles again. So X is the price per hour for loading and unloading. Y is the price per mile. I'm going to work it out. If you don't finish it, you have to watch the video. So in the first equation is going to be represented here. Oh, I lied. It's price per helper here. We're not doing the worksheet until Monday, so if you want, we can watch the video on Monday. I'm going to go ahead and finish it right now. But see you on Monday. Have a great weekend.
I'm at the PowerPoint.
That's the price per worker or helper. So here it's going to be 5 times X plus 80 times Y for that first scenario, the first equation. And the second one they're using 6 helpers, so that's 6 times X and 20 times Y. Sorry? Did you check Canvas? So the equations are as follows. I'm going to use a common product of 30x and negative 30x. So that product, I'm going to multiply this by 6, this by negative 5. Add them together. Nope, not right this second. You gotta wait a minute. Okay, I'm solving for X now. Isolating X. All right, and that X represents, that 60 represents $60 per worker.